they repel, they don't go towards the anode, they don't constitute photocurrent, was considered to be the backbone to explain liberation of electrons take place. If the frequency, I don't want photoelectric current, so what should I do? There cannot be any source which will deliver energy continuously. Hello students, let us continue our discussion on the chapter Dual Nature of Matter and Radiations. In my yesterday's class, we typically understood the significance of the word suitable frequency, meaning to say only when the wavelength of the incident radiation or frequency of the incident radiation matches with the work function of the metal, electrons are liberated. We beautifully understood Hertz's experiment to describe the phenomenon of photoelectric effect, and then we studied the 4 observations or conclusions of photoelectric effect experiment. Continuing students, today we will first understand some basic definitions, fundamental definitions associated with the phenomenon of photoelectric effect. Please to know, these basic definitions are asked for 1 mark in the examination, starting with whatever we studied as threshold frequency. Again, I give the same example. Suppose you need to clear your 10th standard examination, you have to score a minimum of 40 marks. But depending upon your potential, you may score a 50, 60, 70 or a centum. But if you have to be declared as a pass candidate, minimum of 40 marks has to be achieved. Therefore, that minimum of 40 marks is called the threshold marks. Similarly, the minimum frequency of the incident radiations, minimum frequency of the incident radiation below which there is no photoelectron emission is what we call threshold frequency. My dear students, every metal surface will have a defined minimum frequency for the liberation of photoelectrons. If the frequency of the incident radiation is above that minimum frequency, only then liberation of electrons will happen. If the frequency is below that minimum frequency, there is no liberation of photoelectrons, and this minimum frequency is called threshold frequency. Therefore, we define threshold frequency as the minimum frequency of the incident radiations below which there is no photoelectric effect. Liberation of electrons take place if the frequency is above threshold frequency. The next one, we have spoken quite number of times about this, work function. Work function of a metal is the minimum energy given to the electron. It is some minimum energy that is given to the electron to emit it with zero velocity, some minimum velocity. So the energy given to the electron so that it comes out of the metal surface with some minimum velocity is called work function of the metal. And finally, we understand something called stopping potential, a very important definition, quite remarkably asked in the exam. Stopping potential. Students, yesterday we saw in the experiment there was a cathode and an anode. Cathode was a photosensitive surface. Cathode liberates electrons and anode collects those electrons. Now, as soon as the radiations fall on the cathode, as soon as radiations are incident on the cathode, the photoelectrons are liberated, which start moving towards the anode. Now my task is, I don't want these electrons to reach the anode. I want the electrons not reaching the anode. I don't want photoelectric current. So what should I do? Good. I will make the anode negative in potential. Now the anode is negative. Electrons are also negative. They repel. They don't go towards the anode. They don't constitute photocurrent. So what has happened? The minimum negative potential applied to the anode, very important. It is the minimum negative potential that is applied to the anode to stop the photoelectrons from reaching it. We are applying that negative potential so that the electrons don't reach the anode and cause photoelectric current. This negative potential is called stopping potential, or it is also called retarding potential. So, the minimum negative potential I have to apply to the anode so that the electrons don't reach the anode and cause photoelectric current. So these are the definitions of threshold frequency, work function, and stopping potential. Now, a key explanation of this chapter, we will understand Einstein's explanation of photoelectric effect. A very important 3-mark question. How did you understand photoelectric effect? There were photons, there were light of some suitable frequency. It was incident on the metal surface. Immediately, electrons were liberated. But the question is the mechanism as simple as we stated? No. It took years for Einstein to explain the mechanism, and finally in 1914, when he explained the mechanism of photoelectric effect, he was awarded the Nobel Prize. So please to understand, Heinrich Hertz discovered the phenomenon of photoelectric effect. But it was Albert Einstein in 1914 who described the mechanism and hence was awarded the Nobel Prize. Now, let us try to understand how actually the phenomenon of photoelectric effect happens. In 1905, Einstein makes use of Planck's quantum theory to explain photoelectric effect. My dear students, the quantum theory which was given by Max Planck was considered to be the backbone to explain photoelectric effect, and hence in 1905 Einstein is making use of Planck's quantum theory to explain photoelectric effect. What does this quantum theory say? It told energy is given out in small discrete packets called photons or quanta. What Max Planck says is no source of energy is ever continuous in nature. There cannot be any source which will deliver energy continuously. Energy is given out or liberated in small packets, discontinuous packets, discrete packets, and these packets are called photons or quanta. How do I visualize this? Whenever there is a calamity, earthquake, a volcano affected region. You see the defense people, they drop food packets, shelters from the helicopters. In the same way, energy is given out to us. Small, discrete packets, discontinuous packets. And these packets are called photons or quanta. Now, according to Einstein, when a photon is incident on a metal, there is elastic collision between the incident photon and free electron of the metal. Andre, so suppose this is the metal surface, free electron, photon is incident. So what Einstein says is, when the packet of energy, the so-called photons, fall on a metal surface, there is elastic collision between the photon and free electron of the metal. The photon and the electron collide elastically. Incident photon and free electron, they exhibit elastic collision. Now, what is this elastic collision? It is a type of collision where both energy and momentum is conserved. ಏನಾಗುತ್ತೆ, ಒಂದು ಫೋಟಾನ್ ನಾವು ಯಾವುದನ್ನ ಪ್ಯಾಕೆಟ್ಸ್ ಆಫ್ ಎನರ್ಜಿ ಅಂತ ಕರೆದ್ವಿ, when it falls on the metal, it collides elastically with the free electron of the metal. Elastically means to say both kinetic energy and momentum is conserved, which means during collision, the entire energy of the photon is taken up by the free electron. The electron is gulping the energy of the photon. Elastic collision adaga, complete energy of the photon is eaten away by the electron. And now the electron uses this energy in two ways. Elastic collision agide, photon ತನ್ನಲ್ಲಿದ್ದ ಕಂಪ್ಲೀಟ್ ಎನರ್ಜಿನ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡಿದೆ. ಈಗ ಎಲೆಕ್ಟ್ರಾನ್ ಆ ಎನರ್ಜಿನ ಎರಡು ರೀತಿಯಾಗಿ ಉಪಯೋಗಿಸ್ಕೊಳ್ಳುತ್ತೆ. It is using the energy in two ways. First, to overcome the work function of the metal. ಹೊರಗಡೆ ಲಿಬರೇಟ್ ಆಗ್ಬೇಕಲ್ವಾ, ಇಟ್ ಹ್ಯಾಸ್ ಟು ಬ್ರೇಕ್ ದಟ್ refraining forces, surface forces. So it has to overcome the work function and to increase the kinetic energy of the electrons. So what are the two ways in which the electron is utilizing the energy of the photon? First, to overcome the work function of the metal, and second, to increase the kinetic energy. And therefore, Einstein says energy of the photon is equal to work function plus increase in the kinetic energy of the photons. Now, writing in terms of equation, energy of the photon is always written as h nu. So, energy of the photon is h nu, work function is W, increase in kinetic energy. Generally, kinetic energy is half mv square. Now we are increasing the kinetic energy, we are increasing the velocity, so half mv square max. And this classical expression is called Einstein's photoelectric equation. What is that? H nu equals W plus half mv square max. H is called Planck's constant. Nu is the frequency of radiations. So my dear students, here beautifully you learnt how quantum theory, which told energy is always discrete, discontinuous form, photons, helps Einstein to explain photoelectric effect. There is an elastic collision between the photon and the electron. Photon is transferring all its energy to the electron, and the electron utilizes this energy in two ways. First, to overcome the work function. Next, to increase the kinetic energy of the electrons. So H nu is W plus half mv square max, classically called Einstein's photoelectric equation. In my next class, we will understand the observations of photoelectric effect based on Einstein's explanation. And finally, we will also understand why wave theory was not supportive to explain photoelectric effect. Until then, have a nice time. Thank you.